All right, welcome, welcome, welcome to the first devlog 0 of the Cargano game engine. This is not going to be a normal devlog where it's all edited and whatnot like you see normally on YouTube. This devlog, I'm going to do it more or less live, so yeah, just go ahead and bear with me. But let me go ahead and give you a quick peek into what we're going to get into in this video. I have a few screenshots here, so let me see if I can pull it up. There we go. Alright, so for the first screenshot, we got my editor, you can see. This is the engine's editor and whatnot. We have a few primitives, like primitive meshes, so pyramid, quad, and a cube, so that's kind of like my rendering so far. The next screenshot, we have my particle system, so you see I have a little like lerp interpolation for each of the particles and whatnot, and last thing is we have my scripting. So this is all like in editor scripting. I'll go ahead and zoom in so you can see what's going on here. We have a little bit of autocomplete going on when we type through. So autocomplete, linting, error checking, all that works in there. So yeah, we'll get into that. If you want to go ahead and skip to the relevant section, I do have timestamps throughout the video. So yeah, feel free to skip around if you want to. I'll try to go quickly because I know there's a lot to cover in this video. So yeah, let's go ahead and get started. Alright, so what's in this video? So we're going to start off with just introductions, introducing myself, why I'm making the game engine in general, and then also talk about the Twitch stream that accompanies the game engine nowadays. Alright, so the next section, I'm going to discuss just major engine systems, audio, networking, physics, scripting, ECS, particles you saw. I have like a little AI system as well, and etc, etc. So we'll go ahead and get into that. And then the last bit to close out the video, we're going to take a look at the GitHub. And yeah, just check how to access the engine and is it open source? I mean, you see it's on GitHub, so you can probably make a guess, but yeah, we'll get into that towards the end of the video. And yeah, I just wanted to note really quick that each topic is going to be fairly brief since I'm going to be covering a decent amount of material. So yeah, I'm not going to be getting too much into the code, but I'll just be introducing the engine generally. Alright, so what does this devlog cover? Basically, I'm going to be covering from the beginning of the development up until the 13th of January, and then after that point will be devlog 1. So, oh yeah, and I have a note here, the first engine commit was in May of 2023, which makes the development time of the engine so far about 2 years or so, and I was working on the engine prior to the first commit, but yeah, looks like it's around 2 years, so that's interesting. And the next devlog should be in about a month or two. It just depends how much content makes sense for a video, how long I want the video to be, so I'll see, but you can tune into this channel in a few months and you should see if I post it. Alright, so let's get into introductions. Alright, so who am I? My username is LSciCongru. It's a catchphrase from the anime Steins Gate. If you've watched it, then you know what I'm talking about. It's a great anime. If you haven't watched it, I definitely recommend it. I think it was on the #1 spot on my anime list for like a long time. I don't know if that changed. I don't follow that website super closely, but yeah, if you haven't watched it, it's super good. I'm a recent graduate with a bachelor's in computer science. If you know the current job market right now, it's kind of, well, yeah, there's not much to say about that. But I did get introduced into graphics programming during my time getting the degree, right? So, I mean, yeah, that kind of led into the engine, so that's kind of fun. And yeah, I've been trying out streaming. I started streaming a few months ago, and yeah, it's been really nice. It's been really nice. I feel like I was going a little bit crazy working on the engine by myself and not showing anyone. And yeah, it's been nice to just kind of talk with people and kind of get my thoughts out and see what other people are doing and what they think about the engine and whatnot. So yeah, it's been really cool. And I'll get more into the Twitch stream later. Alright, so first I want to kind of, I guess, defend myself because I know game engine development is kind of a contentious topic on the internet and whatnot. Basically, I just want to give my reasons for why I'm making the engine, and also maybe give some downsides as well. So yeah, let's go ahead and get into it. So the first thing is it's fun, right? First reason I'm making the engine is it's fun. It's the most fun I've had in a long time working on a project. So yeah, there's lots of things to get into with an engine. There's always something to work on. That's also kind of its curse as well, as that there's always something to work on. But yeah, I mean, overall, like this is the most fun I've ever had working on like a software engineering project. And yeah, it's satisfying knowing that you created a project all the way from the ground up, right? I've made a few other projects using existing game engines, and there's just like a satisfying feeling knowing that you've built a project all the way from like the basics up until the completion, right? But of course, that's just kind of like a personal thing, right? But yeah, it's a good time. The next thing, and I think is also a really good and valid reason to work on a game engine, is that there's tons to learn, right? And there is tons to learn. There's lots to learn about software engineering. There's tons to learn about game development and everything that goes along with those subjects, right? So, and then specifically for computer science, there's tons to learn and lots of areas that you'll cover, like data structures and algorithms. You will definitely be trying to figure out which data structure matches like what implementation you're working with for a problem you're working on. There's lots of math to be had. Linear algebra is definitely a requirement when you're working on graphics programming. And my engine uses networking, right? So I had to learn about like client server architecture with sockets, UDP, TCP type of stuff. And yeah, there's lots of directions you can take the engine where you might cover different other areas of computer science. So yeah, tons to be had in that realm. And last thing is, you know, your tech, right? So understanding the tech behind the engine allows you to use it more effectively, right? So basically, if you wrote the engine, you know how it works, right? So you don't have to go back and read a bunch of documentation. If you're using an existing engine, of course, if they do a new release of the engine, you got to read the documentation and try to understand what their intentions and how they put things together. But for you wrote the code, so I mean, you know the code, so that's always a plus, right? Now let's get into the downsides. Are there downsides? Of course there are. And yeah, I think the first biggest downside everyone talks about, and I mean is definitely valid, is that writing a game engine takes a long time. Now, of course, it depends on your goals, but if you directly compare someone who made an engine and then made a game versus someone who's using an existing engine and then made a game, that second person who used an existing engine will always go faster, right? Now, of course, there's nuances and everything, but generally speaking, if you're trying to just make a game, just use an engine. Like, they're there for a reason. Okay, the next thing is that you have to support your tech, right? So there's a lot of code that needs to be maintained, and since you're the main one working on the code, presumably, then you need to maintain that code, right? So if something breaks, that's on you, right? Let's see. Oh, and a second note about this part is that having to support your own tech, if you want other people to look at your code and then work with your code, you need to provide documentation and also make sure the code is readable, right? And actually not even just for other people, but for yourself too. If you forgot how the code works, you want to make sure that you can go back and reasonably understand it, right? All right, and the last thing is that you cannot compete with huge companies. That's just a fact, right? Like if you're trying to make an engine to directly compete with Unity, Unreal, Godot, Game Maker, and CryEngine, there's tons of other engines you can look at, but yeah, you're not going to directly compete with them, right? A lot of people who make their own game engine, they're either making it as like a personal project, kind of like me, or they're doing it with like a particular niche in mind, right? Like you're trying to make a game engine for a specific platform that's kind of hard to port for, or you have some specific requirement that's just hard to get into an existing game engine. But honestly, with current game engines and how they work and the amount of extensions you can add to current game engines, that's not really much of a problem nowadays. So yeah, just keep that in mind. Yeah, and I wanted to just be clear that I'm not advocating for anyone to work on an engine. These are just my thoughts having worked on one. So just take it with a grain of salt, right? All right, so let's quickly, I'm gonna talk about just some previous projects I've worked on prior to working on the game engine. So this first one's a little simulation I wrote in Java. That was the language I first learned when I was learning the program. And yeah, just a little simulation, clouds, people, trees, just walking around and whatnot. I like them. I like just kind of seeing what they were doing and whatnot. And yeah, one interesting thing about this project is that there's no graphics API that I'm interacting with it. For this, everything here is written directly into like a color buffer using scan lines. So not a great way to draw graphics if you're trying to be optimal, but it's kind of fun, right? All right, and the next two examples are basically kind of born out of me taking a graphics programming course in college, right? And during that time, I learned a lot of the basics of like OpenGL 3D rendering, right? So like Phong lighting, you can see working in that 3D renderer, basic model loading, and then a 3D camera is implemented so you can see it moving around with that little flashlight kind of effect. And yeah, you can see a little breakout clone that I wrote. It's kind of using the same code base as that 3D renderer, but yeah, both using OpenGL and whatnot. And yeah, some of the issues that I had when I was making these projects sort of led me to work on the engine, because a lot of the code, if you looked at the code base for these, they're very, very messy and not very reusable. And those were the issues that I wanted to deal with when making the engine. All right, last thing is I just wanted to quickly introduce my Twitch stream before I get into the rest of the video. Recently, I've been working on Particles. That's the newest system, and this is just a clip from one of my recent streams. In the future, I'm going to be working on in-game UI more and some networking issues, and once those two things are done, I should be finished with the game I'm working on right now, which is Pong. So, yeah. And also, yeah, the link to my Twitch is available in the description, so feel free to come down there, and then if you want to come by, feel free to come by. I appreciate it. And yeah, if you want to come by, here's my Twitch schedule. I typically come on 1 p.m. to 3 p.m. Pacific Standard Time every weekday, except for the weekends, of course. All right, and then a quick note, if I am going to cancel a stream, I will indicate that in my Twitch schedule tab. And I do also stream longer than these indicated times, but these are usually the times you can catch me. So, all right, and then, okay, one last thing. So if you want to catch up on any of the VODs that I've done, I post all of my Twitch streams directly to YouTube. So on this channel, you can see I have a playlist called Game Engine Stream. You can look through it and then just see me developing any of the stuff that I'm talking about in this video, right? Now, of course, a lot of the content in this video I worked on prior to the stream, but you can see what's in there. All right, so we've made it to the main section of this video, the game engine systems. Hopefully I can go through this fairly fast so that we don't end up going off the rails like here with Charlie. All right, so let's go ahead and get into it. All right, editor user interface. So if you saw the screenshots earlier, I think the thing that probably would have stood out to you was just the editor and its like user interface. It's kind of very specific to my engine, right? All right, so there's multiple windows and panels for managing different assets. You'll see that as I go through many of the various systems. There's an earthy color palette, and I have custom widgets written on top of IMGUI, right? So IMGUI is the main backend, as you can see, right? And also I have a few extra extensions working with IMGUI, such as the IMGUI color text editor and the IMGUI notify for toast notifications, right? So let's go ahead and take a look at it really quick. Here I'm showing the main window of the engine's editor, right? And let me give you like a really quick tour of it. So you can see here that I have this thing will go out of the way. We have the scene editor, and you can kind of see like a scene graph with all of the entities that exist inside of this scene, right? We have a main viewport, and this main viewport has like a play section and a section with some tooltips or for like for viewport options and whatnot. And we have a content browser. So we have all of the assets that are relevant for this particular project, which, as you can see, is Pong, right? All right. And we'll take more of a look at the user interface as we get through the rest of the systems. You'll kind of see it in action. All right, ECS, Entity Component System, right? So here, I'm not going to explain fully what an ECS is. I'm assuming if you've been looking around at different engine videos and whatnot online, you've probably seen this term pop up a few times. There's good videos covering this topic. The main thing that's relevant for my engine is that the ECS maintains an entity to component relationship. So you have like a one entity to many component relationship, and all of the individual components are held in discrete buffers, right? So for example, if you have a transform component that stores the location of a particular entity, that data is stored contiguously together with other transform components in one big buffer. And that helps with performance and whatnot when you're trying to loop through a bunch of entities at once, right? All right, and otherwise for my engine system, I have a custom written project specific component system. So basically inside of the editor, you can write game specific components that are specific to your game, right? So I'll showcase that in a moment. In the backend, we use the Ent C++ library. There's two main libraries that people use for ECS. It's Ent and Flax. They both have their pluses and minuses. Ent is usually better for single buffer look-throughs, while Flax is better for looking at multiple buffers at the same time because they have like archetypes. Yeah, I'm not going to get into that. It's like a whole thing. But yeah, let's go ahead and take a look. Here I'm just showing the scene graph, the one you saw from earlier, and the entity properties in the main window. So if we take a look over here, we can see that we have this player 2, right? And this player 2 has multiple components: tag, transform, rigid body, and whatnot. And then down here, you can see that we have different fields or different data that's associated with every particular component, right? And then if we just click on the individual entity, you can see it shows an entire list of all of the data associated, right? So it's always a good feature. All right, here's a second screenshot showing the custom component editor and a component instance, right? So basically, this is the custom component editor I was talking about earlier. You can create your own components. Here I have a speed component, and the speed component has those three fields. And then if you go to the player 2, you can see we have a speed component right here, right? So you can associate it with a particular entity. And then when you click on that, I think I'll click on it in a moment. Yeah, here you can see that we have all this data and you can modify it for that particular entity. All right, rendering. So this is usually the biggest system in an engine that people talk about. And for good reason, it can get very complex. In my engine, it's fairly simple, and I made it simple on purpose because I wanted to get the rest of the systems working, and especially my asset system in particular, but I wanted to get a lot of the other systems working and get a game done before I go crazy with the rendering. So here I just support basic 2D quads, cubes, and pyramids, right? So mainly just supporting a 2D workflow. And a formal mesh system is on the way. I have ideas for it, but currently I still need to think about it for a bit. And yeah, this is just a typical OpenGL project. Uses OpenGL 4.3. I'm glad to retrieve OpenGL function pointers and then glfw as the main windowing system to get input and whatnot. And of course, those bottom two are required so that OpenGL can work right on your graphics card. And I do have plans for supporting Vulkan and WebGPU in the future, particularly WebGPU. I plan on getting that done fairly soon because I want to port the engine to HTML and JavaScript. You know, you can put it on a web page and whatnot, so that'll be fun. All right, and then here I'm just showing the different primitives that are available in the engine. Again, I said a quad, a cube, and a pyramid. And then over here, you can see that each of these entities, right, has a shape component, right? So if we take a look down here at the shape component, we can see that we have the mesh and then some like shader information. So like color type, flat color, if it's using a texture, projection matrix, this is more like an internal thing, but whatever. But yeah, you can go ahead and edit those things and then, yeah, very simple at the moment, but again, I do have plans for more work later. All right, in-game user interface, right? So if you want to have a heads-up display or menu items used in-game, then of course you need an in-game user interface, right? The functioning of the system is entirely custom written, right? And it uses signed distance field textures to render text. Okay, well, earlier, okay, I just said that it's entirely custom written. The text rendering is not, but everything else is custom written. I guess I mistyped that. But yeah, we use MSDF Gen, and we have MSDF Atlas Gen. Both of these dependencies help me generate text atlases, right? Which can be used to render text, right? But everything else, like the widgets and whatnot, I've written myself. So here I'm showing the user interface editor. Here is an entire window you can see, and then we have basically this hierarchy where we have the main menu. This is the user interface. We have a window, the main window, and a bunch of widgets that are kind of a child of that, right? And yeah, you can see I have some gizmos moving around the widgets. You can do this with the windows as well, and you can kind of move your camera around and mess with it. Typical edit user interface type of stuff. And yeah, okay, let's go ahead and move on. All right, so scripting. So in my engine, I use a custom scripting language that compiles to C++. Hot reloading of scripts is available inside the editor. Basically, my language compiles to a C++ DLL, which can be reloaded while the editor is active. I have linting and error checking provided in the text editor. And yeah, there's no dependencies. I used to use C#, which involved linking mono, which was really annoying. I don't know, getting that whole thing set up was kind of a hassle for me, but yeah, this just uses C++ with C++. All right, and here you can see I'm showing the script text editor with the linting and error checking I was mentioning earlier. And here you can see I have syntax highlighting for like literals and types, and then you have a little dialog box that pops up when you type, so you can do autocomplete for different functions and whatnot. And this is still kind of a work in progress for me. And yeah, you can go ahead and go over to the file here and click rebuild scripts, and then you can reload your scripts inside of the engine. All right, I know that was kind of a big system to kind of gloss over, but I'm trying to get through it, you know what I mean? So here, we got the AI system. So in my engine, the AI system is basically just an engine-managed state machine that's attachable to various entities. The scripts can be called when transitioning between states. So those scripts that I mentioned earlier in the scripting system, they can be attached throughout the engine in different places. So it's all kind of integrated together. And this features a messaging system that allows AI agents to interact with each other, right? So you can send a message from the entity A to entity B, and then you can kind of like handle that however you want with the scripts. Yeah, and I don't really have any dependencies. This was a custom written system on my end. So here I'm showing a game between me and the Pong AI, so it's just an example. And I believe I lose this game, I'm not sure. Yeah, so I lose this game. And over here, you can see that I have kind of different places where I can attach scripts to this particular AI state, right? So you have an on update, so this just seeks the ball on the on update, right? And these on enter and on exit states essentially allow you to do some sort of action when you transition between AI states. And here, of course, we have the on AI message script, so this allows you to handle messages being sent between AI, right? And then in the next screenshot here, I'm showing adding an AI state to an entity, right? So over here, we now have an AI state, and if we look over here, we can attach like a global state, a current state, and a previous state. I believe somewhere over there I just attached a particular state. Let me let this load again. All right, so basically the global state is like an overarching state that you can have generally speaking, and then the current state is just the current state. And then the previous state is kind of a blip state where you can be in the current state, transition to a next state, and then you can just go back if you want to. So if you need that functionality, you can have that. But yeah, it's fairly simple, just managing state machines type of deal for the AI. I do have plans for adding more features, but as of right now, I'm pretty satisfied with it. All right, so we have a physics system, right? So entities can attach 2D circle or box colliders to interact with other entities, and it supports in-editor visualization of the colliders. It's fairly simple. And for dependencies, I have Box2D, which is the physics library, and I do have plans for 3D physics in the future, but at the moment I just need 2D, so that's just where I'm at. And here I'm just showing the debug visualization of the box colliders. So here you can kind of see these green outlines. I can kind of zoom in. You can see it on this static wall, and then also kind of following this paddle, right? And then here you can see that I have a little option I can click, and then it enables or disables the visualization. And then here I'm showing options for modifying the 2D physics settings, right? So if you go to the entity ball, right, and go down to rigid body, this is sort of the material you can think of for the physics interaction, and then the circle collider is the actual like 2D object, right? So if you click on rigid body, you can see that we have options for like handling collision, and also like, do you want it to be static versus dynamic? And then of course for the collider, we can just specify like how big it is and whatnot. And over here you can see that changed a bit when I modified the values. So yeah, just 2D physics, it's pretty decent, right? Again, I do have plans for 3D, it's just not at that point where I need it yet. So, all right, audio. Audio is fairly simple. It's actually probably the simplest system I have. You can import .wav files. It's a pretty simple format and kind of expensive. I need to add more formats later. And we have support for basic playback of sounds and music in-game. In the backend, I use OpenAL, which is a fairly common 3D audio library. There's other options you can use. I just chose this one. It's fairly low level and still lets you kind of like do a lot of the things yourself. And here I'm just showing a basic implementation in the scripts where you can just play music or play sound, and then you specify the name of the audio file you want to. And yeah, I do have plans for changing out the strings to like actual asset literals so that you don't have to type out and kind of guess if it'll work or not. But yeah, it's not really related to the audio thing, that's just in general. But yeah, again, audio fairly simple right now. I will add more features as needed, like attenuation between objects and like Doppler effect and whatnot. If I need that, I'll go ahead and add it. All right, so input. Input, basically, we have two things with input. The first thing is we can query the state, kind of like input polling for the keyboard input and mouse, right? And the second thing is we have a custom input map asset, which provides editable input to function bindings. So if you're ever working in a game or you're playing a game and you see the option in the back in the options menu that you can like change the bindings of certain keys, something along these lines is how that system works, right? Like that's what this asset provides, right? Of course, this is different from their implementations, but it's kind of the idea, right? And here we have glfw as a dependency because we need to pull input from somewhere, and then the windowing system provides the input. And yeah, again, I only support keyboard and mouse currently, but I do have plans for a gamepad at some point. In one of the previous games that I worked on, I believe the Breakout game, I did have support for gamepad, but it was kind of messy. So when I want to add that again, I'm going to have to think about how that's going to be implemented. But yeah, here we have, we're showing input polling and scripts, right? So let me go ahead and zoom in. You can see that it's checking if this key is pressed, right? And then this also has like a polling slot. That's kind of a weird thing. I gotta figure out this API, to be honest. And then here we have like a load input map with the assets. And of course, this is a string. Later, I'll have like asset literals. But yeah, that's basically it for like setting up the input. And then you can kind of see here that we show the creation of a key to script binding in an input map asset. So we have this input map editor over here. And then we have like on update versus on key press versus polling, right? So you can do certain things that you can check for certain keys every on update, or check for a key pressed event. And then it'll just call the corresponding script, right? So human player one move up. And then here you can create a new binding where it just, you select an input and then provide like a function. And then here, I think I'm looking through, I search for like the open main menu, I think. And then here we go. Yeah, we select that one. And yeah, there you go. All right. So networking. networking was an interesting one to implement. I have a basic client server architecture implemented. The server acts as a relay between the clients in a session, right? So the server holds the context of the session and then just relays like physics and location information between the two clients, right? Of course, I could still add a lot more things like server-side validation and like server-side assets and entities and whatnot, but for now, for Pong, this works, right? Yeah, and then the last thing is that the client and server can be exported along with a project, right? So here we have the ASIO library as the main dependency. And yeah, okay, so here we're showing kind of the example of two clients running and then a server running on the same local machine. This does work on the internet, but I still need to fix some issues with that, but it does work in its basic sense. And you can see the physics and everything being synced between the two clients, right? And then this second recording I'm showing, basically I'm showing the exporting of a project, and then along with that you can see that I'm exporting a server. Here you can see I have like, oh, like I missed it, but yeah, we're exporting a server if this is set, and then we can export the client along with the actual game, right? All right, I think we're getting towards the end. So particle system, right? For my engine, the particle calculations are done on the CPU just as like a basic implementation. I do have plans for GPU particles at some point, and it supports spawning with a bounding box, right? So you can spawn it within like an area, right? Supports particle gravity and a few other features like color interpolations and whatnot. Yeah, there's no dependencies in particular other than the backend rendering. And here I'm just showing the particle emitter window. So I open up a particular particle emitter, and then here it's like a floor emitter, so you can see it spawning within this bounding box, right? And then over here we have all these different options for like emitter lifecycle, spawning rates, particle color, and whatnot. So yeah, it's a pretty fun little system I just added in the recent streams. All right, and then this is the last slide. So this is the asset management. So here, this is one of the most important systems in my opinion to get like right before you start working on other things. Here we handle importing, caching, and then exporting assets. We have an asset viewing panel that enumerates all of the project assets so you can kind of see what's in the project. And then we have a content browser that shows your project asset directory, right? No dependencies to list. I think I do have some dependencies for importing assets. If you want to see those, I do have them on my GitHub listed, so I'll get to that part. But here I'm just showcasing the asset viewer panel so you can kind of see flatly all of the different assets that are available. I guess I zoomed in a little too far, but hopefully you can kind of see what I'm talking about, right? With this asset type, file location, intermediate, and like a checksum to see if it changed and whatnot. And then we have a show asset management function in content browser, so you can kind of see I'm in the content browser. I'm importing a texture. And then we have the source file, destination folder, and then like the asset name you want to create, right? Because we need to load it in. And then here you can see I'm creating an asset with all these options that I have. And yeah, we've reached the third section. All right, so it looks like we've reached almost the end of the video. This last section, I'm just going to showcase the GitHub, how you can take a look at the engine if you feel like, and all that stuff, right? All right, so is the engine available? It is available on GitHub. I will skip ahead a little bit just to tell you that it is not exactly usable yet. But the most stable version of the engine is available on the main branch, and then new features are written directly to the dev branch. And when I feel ready to, I will merge dev changes into the main branch. The engine is open source. The engine is licensed using an Apache 2.0 license, so it's fairly permissive. And I do not have any plans of ever selling the engine. I do have plans for selling the games that I make with it, but if anyone wants to try out the engine or do some pull requests, has an issue, wants to just try it out and do whatever they want with their game, you're free to do that. And yeah, again, it's not exactly usable yet. I'm trying to finish my first and second game, which are just little 80s copy games, but I want to stress test the engine first. After I get those two games done, I will make an initial version of the engine along with some documentation and whatnot, just to make it a bit more formal. And yeah, a link to the GitHub is available in the description if you want to take a look. Here I'm just showing the README and the repo. You can see I have kind of a quick start section, so you can kind of install it and then try it out if you want. And I believe at the bottom of this I have some documentation. It's not great, it's just kind of basic. And here I have a list of all my dependencies, so you can go ahead and take a look at that. And yeah, I think that's going to be about it for the devlog. Thanks for, if you did stay this long and you watched the whole video, I really appreciate you staying the whole time. Like, holy crap. Here's all my socials, so YouTube, Twitch, and GitHub for the engine. And yeah, like and subscribe if you enjoyed the content. And again, all my links for social media and the engine are in the description. I do go on Twitch at the times I said at the beginning of the video, and I do post all the VODs on this YouTube channel, so go ahead and take a look if you feel so inclined. And yeah, I think that's going to be about it. So again, thanks for coming by, and later.